Hello everyone, and welcome to another Science Tutor lesson. I'm your tutor Nathan, and this video is going to cover a few key equations in straight line motion. Alright, so if you are writing these down, what I'm going to suggest you do is get a big enough piece of paper so that you can record or write down how we obtain each equation. Many of these equations are obtained from simpler equations. So we start with the very basic ones and move up to the more advanced or more involved ones with time. Alright, so make sure you have something you can record the actual working out of the equations on, and then we start. So the first key equation that we're going to start with is one that you should be familiar with from the very early lessons on velocity and speed. Right? And that's the equation v is equal to s over t for velocity. Velocity is equal to the rate of change of displacement. And this is actually the first key equation that you need to remember. So in the right hand corner of your page, I'll suggest you write the equations. Right? And you can even number them so that you can keep track of them. So the first one is v is equal to s over t. And that one allows you to find the velocity of an object or particle once you know how much displacement it covered and in what period of time it covered that displacement. Alright, so it's a very useful equation. We also discussed in a previous lesson the concept of acceleration. Right? Acceleration, which has the symbol a, is equal to the rate of change of velocity. So we usually say that a is equal to v over t. Sometimes you may see it written as delta v over t. In that case, it's really the same. Delta v just represents the change in velocity, what it changed from and what it changed to. Right? So in many cases, the symbol u, and you may see in some textbooks, u is used to represent initial velocity. Right? This is a new symbol, so please make a note of it. And v is used to represent final velocity of an object or particle. Right? So just make a note of that. Whenever you see u in textbooks or in today's lesson, we're using it to represent the initial velocity of an object, and v just represents the final velocity of the object. In this case, delta v would be equal to final velocity v minus initial velocity u. So delta v is equal to v minus u. Right? So you can substitute that into this equation that we have right here, and so you get acceleration a is equal to v minus u divided by t. And that's another equation to put in your list. So a is equal to v minus u over t, which is the same as delta v over t. Alright, so to derive our new equation, we want an equation that relates the velocity, v, of an object, and this v represents the final velocity of the object, to the initial velocity, u, the acceleration of the object, a, and how long that acceleration acted for, t. Right? This equation will be a little more general. It allows you to use acceleration information and time information and initial velocity to find the final velocity of an object. So it allows you to work in more situations than the simplified equations 1 and 2, which you have already. So you know from equation 2 that a is equal to v minus u divided by t, right? Or in simplified forms, delta v over t. Okay. if you rearrange this equation for delta v, in other words, in terms of the velocity component, then what you get is delta v is equal to at, right? Transposing 4v to make v or delta v the subject of the equation. Now remember, we know that delta v is equal to v minus u. So write that as v minus u is equal to at. Right? And then the last thing to do with this equation is to write it so that you only have one term on the left hand side, the one that you're really interested in finding, the final velocity v. And here we have that v is equal to u plus at. Right? So the final velocity v of an object is equal to the initial velocity u plus the acceleration of the object times the time for which this acceleration took place. Right, so for equation 4, the next equation on the list, we're going to start with equation 1, v is equal to s over t. In some cases, you may see this written as v is equal to delta s over t. The meaning is the same in both cases. Velocity is equal to the change in displacement, s, or delta s, divided by the time in which that change in displacement took place. Right? You can rearrange this equation for s. In other words, suppose you know the velocity of an object and you know the time that it took to achieve that velocity, but you don't know the displacement change that took place to give you that velocity change. Okay? So we're solving for s, so we get s is equal to v times t. Now if the velocity of the car is changing, or the velocity of the object is changing, then we have what's called an acceleration. Now for acceleration, this term, the velocity, is not constant. So you have to modify this equation with that in mind. So for uniform acceleration, in other words, acceleration that has a constant value, where the acceleration is a fixed amount, then s is equal to v bar times t. Symbol v bar represents the average velocity of the particle or object. So just make a note, v bar is equal to average velocity. Okay? So s is equal to average velocity times t. So the displacement of an object is equal to the average velocity of the object times the time over which that average velocity occurred. Now, the average velocity of an object is equal to the arithmetic mean of the initial and final velocity. It's just the mean of those two values, or simply u plus v divided by 2. Alright, so v bar, or v average, is equal to initial velocity plus final velocity divided by 2. And it would make sense, because it's just the average of the two velocities. Right? Remember that we said that v is equal to u plus at. So you can substitute the right hand side of the equation, the u plus at, into this equation right here in place of v. So in that case, what you would get is v average is equal to u plus at all divided by 2, which works out to be 2u plus at divided by 2. Alright, take a look at this equation. 2's cancel, so you get u plus half a t. And this is your expression for the average velocity of the object in terms of the initial velocity, the acceleration, and the time. So now we can substitute, again, everything that we just worked out here for average velocity. So we're substituting this equation right here into this equation right here. Right? So what we get is, remember we had S is equal to V average times T. Right? Substituting into S is equal to V average times T. And we know V average is equal to U plus half AT. So hence S is equal to U plus half AT times T. And when you work that out, you get S is equal to U T plus half A T times T, or half A T squared. This is your next major important equation. Right? So equation 4 is S is equal to ut plus half a t squared. So this equation is used to find the displacement of an object once you know u, t, the acceleration, and then once you know t, you can calculate the term t squared. Right? So equation 4 is S equals ut plus half at squared. Another one to add to your list. We know that we can find the velocity of an object once we know the displacement and the time that that displacement occurred over. We can also calculate the acceleration of an object if we know the final velocity, initial velocity, and the time that the change in velocity took place over. We can calculate the final velocity of an object, v, once we know the initial velocity, u, the acceleration of the object, a, and the time that that acceleration took place over, t. And we can calculate the displacement of an object, s, once we know the initial velocity, u, the acceleration, if any, of the object, a, and the time that we are considering in this case. Right? Now, the fifth equation that we're going to do will allow us to relate the distance traveled, or the displacement of an object, and the final velocity of the object. Notice that none of our equations relate v and s. In some cases, you may not be able to get all the information you need for solving a question if you were to use equations 1 through 4 alone. Right? So we're going to derive an equation that relates the two terms v and s, along with some others. Right? So equation 5. You may be asked to find the final velocity of an object, and only given the initial velocity, the acceleration, and the displacement of the object. So the final equation we're going to derive today will allow you to calculate v once you know u, a, and s. Or, if you're given any three of the terms in this equation, you'll be able to calculate, or any three of the parameters in the equation, you'll be able to calculate the last one. Right? And it is another useful equation. So for equation 5, we're going to start with equation 3. V equals u plus at. Right? Next, we're going to square this equation. And by squaring it, we just mean multiplying it by itself. So we have v squared equals u plus at all squared. Now remember that since this term on the right hand side is in brackets. We're going to square both sides of this equation, and we get v squared is equal to u plus at, all in brackets, all squared, which is not equal to u squared plus a squared t squared. Alright, that is not correct. What you should have instead is v squared is equal to u squared plus a squared t squared plus u a t plus u a t. Alright? And this is just in case you don't see how we got this. If you have in brackets two terms, a and b, that are added or subtracted from each other, and you square them, then the procedure for squaring it is you multiply a by itself, so you get a squared, then you multiply a by b, so you get ab, then you multiply b by itself, so you get b squared, then you multiply b by a plus ab. So what you get is, in the end, a squared plus 2ab plus b squared. Alright? That's just for those who are not sure how we got this result down here. Right? In this case, u is equal to a, ab is 80, and b squared is a squared t squared. Right? So back to equation 5, we get u squared plus 2u at plus a squared t squared. Right? Another way of writing it is that v squared is equal to u squared plus 2a, and in this case we're factoring out the 2 and a, and so we get v squared is equal to u squared plus 2a ut plus half a t squared. Alright, the reason for this half, this 1 over 2 that you see turning up, is because this a in the equation above was by itself. In other words, it was being multiplied by 1. When you factorize out the 2a, you have to multiply the a that's remaining, this a right here, by a half, so that when you multiply the 2a by the half inside the brackets, if you wanted to work in the opposite direction, you'd get back 2a times a t squared, so you'd get a squared t squared, which is what you started out with. Alright, so that's where the half comes from. Right? If you don't understand it, please go over the explanation, work it out for yourself, make sure you get it. Right? What I want you to notice is that in the brackets we have something that looks very similar to equation 4. S is equal to ut plus half at squared. Here we have ut plus half at squared. What this means is that we can replace everything inside of these brackets with s. And when we do that, it gives us equation 5 in its completed form, right? Which gives v squared is equal to u squared plus 2a multiplied by s. And that is equation 5. So equation 5, v squared equals u squared plus 2as. Right, and what this equation allows you to do is to find the final velocity of an object once you know the initial velocity, the acceleration, and the displacement that this acceleration took place over, right? Or the total displacement of the object during the period that we're considering. So please make notes of these equations. These are very important for you to know and be familiar with, to have that ease in doing exams that we all want you to have, and that I'm sure you want to have as well. Alright? So thank you for watching. Please make sure to like and share the video, and stay tuned for the next video in the series. Thank you.